Welcome to Homework Lib.
Two triangles have two corresponding angles and one corresponding side that are equal. Are the two triangles congruent? In this question, we need to consider two triangles with two angles and a side that are congruent. As an example, we could start with any triangle, such as one like this. If we consider two angles and the side in between them, then if we draw another triangle that has to have congruent corresponding parts, it would start by looking something like this. The corresponding side will be the same length, and the two angles we have are restricted to being the same size as in the first triangle. In this way, there is only one way to complete the second triangle, and it will be congruent to the first. In fact, the angle-side-angle congruency criterion tells us that two triangles are congruent if two angles and the side drawn between their vertices in one triangle are congruent to the corresponding parts in the other. This is equivalent to having two pairs of corresponding angles and the included pair of sides congruent. But notice that we weren't told that the side has to be included. So would the triangles be congruent if we chose a different side? Let's go back to this first triangle and think about the angles in the triangle. We can recall that the angle measures in a triangle sum to 180 degrees. So the measure of angle A is equal to 180 degrees, subtract the measure of angle B plus the measure of angle C. And because angles B and E are congruent and C and F are congruent, then the measure of angle D is also equal to 180 degrees minus the measure of angle B plus the measure of angle C. And that means that given we have two pairs of angles congruent in two triangles, then the third pair of angles in the triangles will also be congruent. So let's consider the problem. If we have two triangles that have two pairs of congruent angles and a non-included side congruent, we know that because the angle measures all add up to 180 degrees, then this will be equivalent to having two angles and the included side congruent, and the triangles will be congruent by the ASA criterion. The same would be true for the triangles ABC and DEF, if we use the sides AC and DF instead. In fact, this can be referred to as the angle-angle side or AAS congruence criterion. Knowing that two pairs of corresponding angles are congruent and the non-included sides in each triangle are congruent would prove that the triangles themselves are congruent. We can therefore give the answer to the question as yes, since because we can work out the third angle when given two angles in a triangle, then when two angles have two corresponding angles and one corresponding side congruent, the triangles will be congruent.